looking at the topic of tuples and sets. Tuples and sets, these are two kinds of data structures in Python, and they are quite different. They are used less than your dictionaries and lists, and I'll be covering them in really less detail because of that, but they are nonetheless important data structures contributing to the whole of Python. So tuples. Tuples are data structures. They are very similar to lists, but they cannot be modified once created. So really, they are like fixed lists, where you create a tuple, you put things in it, and then you can't change it. They are locked in, fixed, they are constant data structures. The common term used is immutable, meaning cannot be changed. Mutable, like mutate, means able to be changed. Immutable means not able to be changed. They can be indexed and sliced like lists. Their set of available functions is similar to lists with the omission of functions that would modify them. So I don't list the functions here in this module that are available with tuples, but really they are the functions that the same functions you would use for lists, other than the ones that would modify because a tuple can't be modified. An example would be a thing like sort, a function like sort. It modifies the list. It sorts them in ascending order. You can't use sort on a tuple because once you put the information, once you put the data into it, those locations are fixed and they cannot be moved around and sorted. So things other than sort would be available. Let's look at initialization of the tuple. Tuples are initialized using surrounding parentheses with data items inside separated by columns. To initialize a single element tuple, a comma is required after that single element. If the comma is not included, it's going to be interpreted as a single value inside of parentheses. And you'll see what I mean after this first example. This first example, a tuple is created with parentheses around, and then you have the data items separated by commas just like you would with a list. So really the distinguishing characteristic of the look of the tuple is the parentheses. And in Python, the data structures are really differentiated by the enclosing symbols. A list has the brackets enclosing. A tuple has the parentheses enclosing. The dictionary has the curly braces enclosing. So you see here, the pattern is that the enclosing symbol kind of tells you what kind of data, or what kind of data structure, data type the stuff is. Let's look at this next example. In this next example, this is what I mean with the, if you're going to initialize a tuple that has only one element, you must put a comma after that one element, or else it's going to be interpreted as a single value inside parentheses. So it's going to be interpreted not as part of a tuple, it'll be interpreted as a single value. So the comma afterwards is important. Next thing, usage. Scroll up, scroll up. This really is how you use tuples. So a tuple can be indexed and sliced. We've seen indexing in other modules where you, just like a list, this is going to get indexed to the third element of the tuple. And then this next one, this is a slice going from 1 to 3. And it says print elements from index 1 to 2. That's because the upper limit is not inclusive, where it's going to go index 1 and 2, and it's not going to do 3 because slices, the range of a slice is not inclusive. But the slicing works just the same way it does with a list or a string. Tuples can also be concatenated like strings can, where You take a tuple, tuple 1 and tuple 2, here shown as T and U. If you do a plus symbol on them, what it's going to do is combine them into one tuple, and the new tuple is V. It does not modify the two tuples because tuples are not able to be modified. It's going to create a new tuple, and that tuple's name will be V. So tuples can be concatenated. And here's a little tip. Lists can also be concatenated, although I didn't cover that. So take that little nugget and run with it. So here, this is about functions. List functions that do not modify the data will work. So really, look at all the list functions that do not modify data, and you can use them with tuples pretty much. And here I'm going to look at the count, and the index functions, where I've got a tuple here, and you get the, remember, count is going to give you the number of occurrences of a value. So if I get the count of 12, it's going to give me a 3 because there's 3 12s in here. Looking at index, index is going to give me, index of 7 is going to give me the numeric index of 7, which is going to be 5 because you start 0 here and 5 here. 1, 2, 3, 4. It is the 5th index. So list functions can work on tuples as well. Here is another point about tuples. This is really about use cases of tuples. Tuples are going to be used for data that does not change. And there are some important use cases of that. It can be used for fixed data like coordinates, RGB data, which is red, green, blue color data, or storage of a reference chart like an alphabet, things that do not change. And here's some examples. Tuple T has coordinates in it, like a latitude, longitude type of thing. Of course, the location of a city is not going to change, at least not anytime soon, right? So the latitude, longitude of the city Miami in Florida, it's going to be fixed. It's not going to change. So you could throw that into a tuple if it needs to be part of a data set that you're using in Python. So that's a good example. Another example is the alphabet. Alphabet doesn't change. So you could throw it into a tuple, and you could have the letters at fixed locations because A is always going to be the first letter in the alphabet. So if you need to use that in your code, you can go ahead and do that. And these last two examples are really this is color data like RGB, where you have separate numbers for the amounts of red, green, and blue, and these amounts will not change for a certain color. So red's going to be these 3 color combinations. Yellow is going to be those 3 color combinations. So there is a talk about tuples, folks. Now we're going to look at the data structure of sets. All right, looking at sets. What is a set? A set, or sets, they are unordered, mutable, meaning changeable, like we covered in the last piece. Tuples are immutable. Sets are mutable. Sets are unordered, mutable data structures containing only unique elements. Only unique elements. That is important. Sets are unordered and cannot be indexed. That's another important point. If something is unordered, it cannot be indexed because indexing refers to order. Think about indexing a list where you have index 0, 1, 2, 3, whatever. This is the ordering, the location of the data. Sets are unordered, thus they have no locations. And the order that a set is in right now could change the next time you retrieve the set. So you can't rely on the order of a set. They are unordered. They are just, think of them as, well, unordered. Can't think of an analogy quick enough. It doesn't matter. Okay, let's talk about creating sets and a little bit of usage. Sets are created by enclosing comma-separated data inside of curly braces. An empty set is created using the set function. Now, I talked about the thing in Python that separate data structures are really, they are almost identified by the enclosing symbols that they use. Like lists have the square brackets, tuples have the parentheses, dictionaries have the curly braces, and also, guess what? Sets have the curly braces as well. So sets and dictionaries, they share the curly braces as you see here. And there's a way to differentiate between them, of course, because the way to differentiate is that dictionaries have key value pairs separated by a colon. Sets are single values separated by commas. So the Python interpreter can tell what kind of data it is, set or dictionary, by the nature of the element. If the element is a pair separated by a colon, it's going to recognize it as a dictionary. If they are single values, it is going to recognize them, or it, as a set. So let's look at set creation, folks. Set creation. In the beginning, there was sets. So here you have 3 strings in a set. Next line, you have an empty set. In the third line, you have an incorrect initialization of a set. See, the curly braces, the empty curly braces are, that syntax is reserved for dictionaries. So this is kind of what you run into when you have data structures sharing enclosing symbols. You have rules like this where the empty curly braces means dictionary, so a set can't use that. Instead, sets have to use the set function to create an empty set. So that is the rule with that. Let's move on to an important characteristic of sets. Because sets do not allow for duplication, they can be used to remove duplication from other data types or data structure types like lists. You can use a set to remove duplication from data. A list containing duplicates can be converted to a set, and then the duplicate values will be removed in the process. So take a look at here, where we have a list that contains duplicated data. Notice that there's duplicated 1s and there's duplicated 3s. What if I want to get rid of the duplication without doing some complicated, convoluted process? Sets are going to come to the rescue. Look at the next line. I convert my list to a set using the set function, and then I put it into this variable s, and look at what s is going to contain. S is going to contain a set consisting of all the unique values from the original list. So what I could do from here is convert it back into a list, and then I have an unduplicated list. And I will demonstrate this one. This is important enough. This is a very prominent use of sets, where you use them to deduplicate lists. I'll get rid of that for now, or actually forever. Okay, so we have the list with duplication, and then we've turned it into a set. Let me go ahead and print what's here. You see that? So the data is deduplicated, but notice it is a set right now, shown by the enclosing symbols. It's a set. I want to turn it back into a list. So there's another function appropriately called list that I can use to convert it back to a list. I'll use my same name, same variable name, and I'll convert S to a list. And now duplist will contain the deduplication, but now as a list. So here it is, folks. You start with duplication, you convert to a set, then you convert back to a list, and then the duplication is removed, and we have our deduplicated list. That's what I wanted to impress upon you. Hopefully you are impressed upon. And just to wrap it, I'll get the type of the data. Of course, it is a list because it's enclosed in square brackets, but it is a list. So I've taken a list that contains duplication, converted it to a set, and then back to a list. Magic. Voila. However you say it. The duplication is gone. Gone, folks. I don't say it to impress you. I say it to impress upon you that it is gone. Wanted to use that line. Okay. Set functions. So here's a couple of functions that you can use with sets. Important ones called add and remove. These two functions will add or remove from an existing set based on value. Sets are unordered, so the addition or removal cannot be based on an index because there's no indexes in sets, folks. So what we got here, we got a set of strings. You add a string, you remove a string, and you see the result. I'm going to pop this in just for the, well, just for the heck of it. I'll keep it clean for now. So looking at this, you have a set, you add a D, and then you remove a B. See what we get afterwards. Just printing S. A, D, C, because D was added, so it's there. B was removed, so it ain't there. Magic. All right, here's an important section. They're all important, right? That's why I'm going over them, but this is something that makes sets pretty useful. The set data type contains a set of functions that utilize mathematical set operations useful for combining and filtering data. If you have any familiarity with basic algebra, there are operations called union, intersection, difference, and symmetric difference that you can do on numbers, on sets of numbers. Well, in Python, you can do these operations on sets of data, and it's a pretty valuable data organization tool, these are, to do operations on different kinds of data. And perhaps you'll see the value as I get into these functions. Those set operations that can be done are the union, the intersection, the difference, and the symmetric difference. And I'll cover each, of course, one by one. Looking at union. These aren't the good guys in the Civil War. The union, it's a union of two or more sets. That's what it is. So I want to frame it before we begin. These operations are done on two or more sets where they are kind of like combining and filtering operations. It's a way they kind of generally say it, but it's kind of doesn't get to the heart of what's going on. Getting into the heart of what's going on is about to happen now. With union, the union of two sets is the set of every element in both sets. And if this was more than 2 sets, it would be every element in all of the sets. I want to let you know that I'm doing examples on 2 sets at a time, but any of these operations can be done on multiple sets, like across more than 2 sets. 2 sets will be the example, though. So the union is every element in both sets. And it can be done with the union function or the vertical line operator. Another thing about these set operations is that they can be done with, each of them can be done with a function or an operator. It's a very flexible kind of thing. Kind of cool. Always more than one way to do things in programming. All right, so we have 2 sets here. And then here we get the union set A union set B. As the definition states, it gets everything in both sets, and that's what you get here, everything in both sets. See how it's happening? If you're saying so, I can't hear you, but hopefully you get it. If you don't get it, stare at it, watch it again. Okay. Next one is intersection. Intersection, these are the elements that are common to both sets, performed with the intersection function or the ampersand operator. I believe that's how you say it, ampersand. Correct me if I'm wrong, but I, of course, can't hear you. Here we have 2 sets, set A and set B. And here we get the intersection of set A and set B, where the elements common to both. So let's eyeball it and look at the elements common to both. Let's see, we have A's, we have C, and that's it. So the set would be A and C. So you see how this is working? This is like kind of a regrouping of data or filtering or whatever word you want to put in there that makes sense. It is, right? But pretty cool stuff. A way to reorganize data according to according to the criteria that you want. Yeah. Difference. Difference is the set of all elements in the first set that are not present in the second set. To perform it, you use the difference function or you use the minus operator. Emphasis on this, minus operator. Difference is minus, just like in mathematics. Subtraction, I know you were told that subtraction is the difference between quantities. Well, you use the minus to do the set operation as well. Okay, 2 sets. And then we do A minus B. It's the elements in the first set that are not present in the second set. So it's like it's a one-way deal where it is things present in A that are not present in B. So you have A, B, C, C, D, A. What's present in A that is not in B? It happens to be B. So there's your outcome there. And for these next 2, I'm going to run them in our buddy Python. Charming, charming, charming. Okay. But the outcome is going to be what you would expect, so got that. See, the things that are in set A that are not in set B, and that would be the B. Looking at the next one, it's a different kind of difference, which is an interesting way to say it. We have the symmetric difference. The symmetric difference, it's the set of elements that are unique in either set, performed with the symmetric difference function or the caret operator. Interesting one. It may be on the number 6, depending on the keyboard you got. Symmetric difference, it's a different kind of difference where these are the elements that are unique in any of the sets. So comparing these two again, we know that B is unique from A to B, but in this other set, D is not in A, so it's really a difference that goes both ways. The regular difference is a one-way. It's things that are in set A that are not in set B. Symmetric difference says these are the things in set A that are not in set B, and the things that are in set B that are not in set A. So it's a difference that goes both ways, symmetric. It's symmetric. Boogie, woogie, woogie. Please don't close the video because I did that. But anyway. Well, the video is about to be over anyway, so you'll be able to close it soon, or I'll close it myself. This is the last piece. So looking at symmetric, no, this is not symmetric. Oh, wait a minute. I have, yeah, this is a typo, folks. I'll correct that right now, because this is an editable copy. Using the wrong symbol. So the caret right here. All right, so what we have here is symmetric difference in PyCharm. Check it out. And we have down here D and B, because B is unique from A, and then D is unique from B. There it is, folks, symmetric difference. And yeah, you can do some really basic data science stuff with these set functions. Cool stuff. Okay, folks, now you can stop the video because I'm out of material. This was Tuples and Sets, and I'll see you, and you'll see and hear me in the next module. See ya.